Thanks so much for tuning in. This is Andy with the Poor Proles Almanac. Following up with last week's episode on the relationship between the microbes in the soil and nitrogen available for plants, we're joined by the man responsible for many people getting fascinated with soil science, Jeff Lowenfels. If you're not familiar with Jeff, he describes himself as an, in quote, reformed lawyer, in quote, who also happens to write the longest running garden column in North America, having never missed a week in 41 years. The combination of garden writing and law earned him the moniker of America's Dirtiest Lawyer. He is the former president of the Garden Writers of America, a GWA Fellow, and in 2005 was inducted into the GWA Hall of Fame, the highest honor a garden writer can receive. Jeff is also the founder of a now national program that started as Plant a Row for Beans, the soup kitchen in Anchorage, and is now Plant a Row for the Hungry. The program is active in all 50 states and Canada and has resulted in millions of pounds of produce being donated to feed the hungry every year. As of this recording, Jeff has just released his newest book of the Teeming with series. You might be familiar with Teeming with Microbes, Teeming with Nutrients, but his newest book, Teeming with Bacteria, sheds an entirely new light on some of the most cutting-edge soil science research, and that's what we're here to talk about today. But please, before we jump in, if you've been listening to this podcast for a while, hit pause and give us a review on the podcast service you stream from, if that's an option. It has a huge impact on our ability to get recommended to new listeners and lets us know how we're doing. And it's also a really good metric for us to refer to when trying to get great new guests like Jeff on the show. We'll be right here when you're done. I hope you all enjoy this conversation. Jeff was a pleasure to talk with, and I'm sure we'll be having him back on again in the future. Jeff, thanks so much for coming on. Would love to get a little bit of your background and how you ended up kind of being the soil guy.
Good question. I ask myself that question every night when I go to bed. I grew up as a gardener. My father was a big-time gardener. His father was a big-time gardener. And they had gigantic gardens and lots of different plant interests and botanical interests. A guy worked for them who ended up founding a company called Miracle Grow. And so we were Miracle Grow gardeners. One day, I remember my father brought home J.I. Rodale for dinner. And he became organic after that. And so I had a little bit of a smattering of organics, but it didn't matter to me that nitrogen came from a manure or whether it came from a green powder or a liquid chemical fertilizer. To me, nitrogen was nitrogen. And I never could figure out really why I needed to be organic until a friend of mine sent me that classic picture that's in the first book, Teeming with Microbes, of a fungal hyphae strangling a nematode as the fungal hyphae protects a tomato root. Oh my gosh. It drove me nuts. And long story short, I became exposed to Dr. Elaine Ingham, the guru of the soil food web. And it just makes so much sense that plants should be growing under a natural system and that the soil food web is a description of that natural system, that I became a big coherent or adherent and offered to write a book about the soil food web for Dr. Elaine. And so I didn't invent any of this stuff. I'm an attorney by trade. I'm an idiot by life. And so in order to understand this stuff, I had to dumb it down so that I could understand it. And somehow that resulted in the first book, Teeming with Microbes. I wrote another book because I thought the first book describes how the nutrients get into the soil, which, just as an aside, photosynthetic energy by the plant produces exudates, which drip out of the root system. They attract bacteria and fungi who need the carbon that are in those exudates, and they're right there by the root system in the rhizosphere. And along come nematodes and protozoa who eat the bacteria and fungi, poop out the excess, and lo and behold, it's in plant usable form out there in the soil, and then it migrates into the root. Well, how does it get into the plant? I wanted to know. And so I wrote a second book called Teeming with Nutrients, which talks about the trip from the soil into the plant and what happens once these nutrients get inside the plant. And then I wrote a third book on mycorrhizal fungi, because we now know that 90% of the plants on Earth associate with a mycorrhizal fungi. They are capable of bringing tremendous amounts of nutrients as well as water into root systems of plants. And then I wrote this last book, which just came out a couple of weeks ago, called Teeming with Bacteria. And it describes a new portion of the soil food web. I guess that's the better way of putting it. Some of these bacteria don't get eaten up by the nematodes and the protozoa, but rather go inside the meristem cells, the very young cells in the roots. And there they fix nitrogen, not necessarily willingly, inside these plant cells. And while they're in there producing nitrogen, they also end up feeding the plant other things and creating root hairs so that they can go back out into the soil and regrow and renutrify and go back in again and do this trip again. It's really quite something. So I just have a curiosity about all of this stuff. And the soil food web to me is like geometry. It's beautiful. It fits together perfectly. It is the answer to our woes, I think, in terms of soil structure, in terms of nutrients in our foods. And so it's just something that just captivates me.
I think the piece that really ties it all together is that you're really passionate about it. And I think that comes across in the books. And it's very accessible, which is, I think, something that is so important, because there's so much academic information out there that if people knew, we wouldn't live the way we do if what researchers were finding out was applied in the world around us, right? And that goes to growing food, that goes to everything we do, basically. Like, we have researchers discovering amazing things, and people just don't know about them. And that's unfortunate, because all it takes is somebody who can read it and understand it, digest it, and spit it back out in layman's terms. And you can say, like, wow, we can make some, slight shifts in the way we do things, and the world would be a lot better, like, for all of us.
Right. And that's exactly what happened with this last book, Teeming with Bacteria. The true name of it is Teeming with Bacteria, the Organic Gardener's Guide to Endophytic Bacteria, which are bacteria that live part of their lives inside a plant and part of their lives outside of the plant without harming the plant. And the rhizophagy cycle. Now, that's how I pronounce the word, Rhizophaggy, rhizo meaning root, phagy meaning eating, root eating. And it's just such an amazing new part to the soil food web that a gentleman named Dr. James White in Rutgers, New Jersey, at Rutgers, is having trouble getting traction, getting people to understand. Just as Dr. Elaine Ingham had people that weren't aware of the soil food web. Today, I think all gardeners are aware of the soil food web. It's part of our lexicon now. We understand this is how it works when we don't use chemicals. And Dr. White's research on something that was discovered in Australia is really mind-boggling and adds to what Dr. Elaine Ingham came across and developed. So it's really an important aspect of the soil food web, and it's just an amazing one as well. It's incredible.
Yeah, and I don't think I feel confident enough to try to explain it in the way I've heard you explain it. But one of the things that kind of stood out to me as I was listening to the relationships between the bacteria and the roots, and how it's not clear, like, to each other in a sense that they're working together, but they very clearly are. And I think it speaks to you would think of it as like a hierarchy where the plant's the biggest thing. So that's the thing in charge. It's the one photosynthesizing, and therefore it's dictating the terms between itself, the bacteria, and the fungi. But it's a lot more complicated than that. And everyone's kind of closer to like an even playing field, right? And I think that's like a really beautiful thing when you think of it within the framework of like complex system science. It's basically that nested system at its most basic fundamental biological level.
It's the way society should work as well, probably. But it's a very interesting situation because the plant is in control. I mean, the plant the plant does signal to the bacteria as well as to the fungi, come, but it's a very complex dance. And normally bacteria and fungi are not inside plants. Let's take bacteria because I think people can understand this. They're not normally inside plants. They don't belong there, and so the plant's reaction is, wait a second, I'm going to bring them in, but I got to really control these guys or they're going to take over and eat me up. And that's what bacteria would do if there wasn't this mutualism that goes on once the bacteria are enticed to go inside the plant. And just so that your listeners understand what happens in this rhizophagy cycle, and just as an aside, I say rhizophagy. Dr. White and the woman who discovered it in Australia say something like rhizophagy. And it occurred to me the other day when I was doing an interview that the reason they say that is because she's Australian. So I think they pronounce it the Australian way. I pronounce it the New York way, rhizophagy. But in any case, what happens is the bacteria, some of those bacteria that are attracted, they're attracted and signaled that it's okay to go into the plant meristem cells. And so they go into those cells. And once they go in the cell, the plant goes, ooh, wait a minute, and sprays them with a superoxide that strips off their cell wall. So you end up with these, and absorbs that nutrient that's in those cell walls, which happens to be some metals and some of the minor nutrients. The bacteria goes, wait a minute, I don't like this. And so it produces nitrates, which counteract the superoxide and get converted into nitrates, which the plant also absorbs. And so you've got this dance going on. Now, the bacteria also produce ethylene, helps the cells grow because ethylene is a phytohormone, causes the cells to grow and stretch. While that happens, some of the carbon that might have gone the oxidate system actually feeds these bacteria so that they can continue to produce the nitrite, which gets converted into the nitrate and continues to feed the plant. Up to 30% of the nitrogen a plant gets can, at least as far as the research so far that I've been able to see, can come from this internal nitrogen fixing, because that's what's going on. And eventually what happens is you get so many of these bacteria, because they multiply every 20 minutes, that they back up against the cell wall of the root meristem, and their ethylene is concentrated and causes root hairs to grow. Now, you and I were introduced to the idea that root hairs are for absorbing nutrients, and they have more surface. They give root more surface area, the plant more surface area, and they can access places that the root itself can't because they're too big. And that's true. That's what they do. But they're produced by these bacteria. So if you don't have the bacteria, you don't have root hairs. Your plant goes crazy and doesn't grow right. You put the bacteria back in, root hairs develop, the plant gets back to normal. And then they concentrate inside the root hair, and they shoot out of the root hair into the soil. They regrow their cell walls, and then 2 days later or so, they go back into the plant and repeat this trip, feeding the plant again. Meanwhile, the root hairs have moved up the system because the root's growing, and they move up the system and they start continually to absorb nutrients, like you and I were taught that that's what they did. We were not taught about the bacteria. And the implications of this, I'm sorry, you can hardly shut me up, are pretty important for growers. I mean, if you don't have a healthy bacteria population, you're not going to have a lot of root hairs. You might have root hairs, but you won't have as many. And so chemicals, we know, cause these bacterial populations to shift. They reduce the nitrogen fixation that occurs inside the plant because the plant doesn't need to do it. It's getting nitrogen. And so you really upset the system. It's not in balance. And you end up with fruits that aren't in balance and vegetables that aren't in balance, et cetera, et cetera. Yeah. It's really an amazing thing. As are mycorrhizal fungi, which operate somewhat similarly, they go in between the cells, as are rhizobia, which we do understand, which form, these nodules causing a root hair or maybe the plant causes the root hair to form these nodules where the rhizobia can live. So this is all part of the soil food web. It's just not something we concentrate on.
Yeah,
and now we should, because it's just as important as the microbial mediation through the soil into the plant.
Yeah, and if you're talking about 30% of the nitrogen a plant's receiving, that's not an insignificant a number.
No.
And it gets me thinking, you mentioned that this is primarily in the form of nitrates, and what the implications are for this process in terms of how it's done, or if it is done with things like trees that don't primarily utilize that type of nitrogen.
Yeah, it's done with any plant that has a root hair.
Oh, wow.
Period. I mean,
Awesome.
As far as I know, any plant that has a root hair, that's what's going on in those root hairs. That's why those root hairs are there. So we have to fundamentally change our view of some of these things. Now, there's one other thing I have to add, or two. There's lots of things I can add. First of all, when the bacteria goes into the plant and the plant sprays the bacteria with that superoxide, the plant has to strengthen itself. It has to strengthen the cell, or the cell itself has to strengthen itself to be able to withstand that superoxide so that it doesn't destroy itself. And so it becomes more resilient. It becomes more capable of handling stress as a result of the bacteria entering into the. So it's a real win-win for the plant. For the bacteria, they get a place to multiply where there's no competition, and that's a win-win for them. And in the long run, you end up with more of them in the soil than you would have had they not gone through the rhizophagy cycle. But what's often ignored is the role that bacteria play in formation of soil structure. We only have, they tell me, 60 years of soil left. Whoa, because we're not treating it well. The bacteria produce a slime. That slime is where soil structure begins. It sticks together individual particles of soil. They're not bricks. They're irregular shaped. So you get air holes, you get reservoir space for water. You get places where the little guys can hide from the big guys. And then it gets woven together by the fungi. And so this is where soil structure comes from. And when you apply chemicals and upset the bacterial balance, as well as the fungal balance, I might add, you don't end up with soil structure. You end up with soil that gets combined over and blown up into the air. Not good.
No, not at all. And this whole process, and honestly, all of your work has caused me to start thinking more thoroughly about a lot of the traditional ways that we build soil, right? So we've got traditional hop composting, vermicomposting, things like bokashi and Korean natural farming, jadam, all these different things which utilize different methods to grow certain populations of bacteria and fungi. And I'm curious if this process has made you these discoveries have made you rethink the materials you're using, the ideas of inoculation, and what impacts these things might have on, or how this research impacts the way you think about these processes.
Yeah, well, I mean, I still think of the soil food web as the base, and all of these other processes, Korean natural, they all eventually end up being part of the soil food web, providing food for it. KNF uses a lot of stuff that's anaerobic that ends up getting aerobic, but it's all soil food web. It all boils down to that. The Japanese systems, and they're all good. Don't get me wrong. I think they're all great. They all work. People have had success using one, using the other. To me, I'm just a soil food web gardener and grower. And so I know that the system that's described now, we've got rhizophagy and the 2000s, what I call the 2006 system, merged together. It's very easy to use it, and it's very easy to apply it to any kind of system you want to use. So, for example, there is a difference in the bacterial mix. Well, I mean, it's just, if you're using the natural system, you're using the rhizophagy endophytic bacteria. You get them from seeds, basically. They're in the soil. But what happens is they get into the plant, they move throughout the plant, they end up in the flower, they get caught up in this in the formation of the flower and in the seed coat in particular. And so your plant may have 9,000 different kinds of bacteria in that seed coat. And when you put that in the soil, they jump out of there, multiply in the soil, and they're there. And so if you've got a corn plant that's 400 years old, the plants today have the same bacteria. Whoa, your cannabis that is a landrace has the same set of bacteria today that it had 400 years ago because they're in the seed and they jump off. You start taking cuttings, you start changing the system, et cetera, et cetera. The kind of compost you use has different kinds of bacteria in it. What bacteria is best for your particular kind of plant? Now, we're not quite there yet in terms of being able to identify the bacteria that you might need, but we do know that the databases are already there. What we don't have is the ability to take the instrument as lay people, other than sending in a sample and waiting 3 weeks and $500 or even more and getting an answer. But it's coming. And I think in the next 5 or 6 years, we'll have something where we can, like the microbiometer, where you can point the cell phone at a water mixture and it'll identify the DNA, or put a probe in that you can plug into your phone. It's all coming and it's all going to be phenomenal. But right now we know, you've got seeds that contain this stuff. Don't sterilize your soil. Don't sterilize seeds. No hydrogen peroxide. If you're starting seeds in paper towel, make sure you plant the towel along with the plant, because the bacteria are in the paper towel. There are specific bacteria that farmers now have access to that we as lay people should be able to get our hands on. And more of us are capable of doing so. A lot of the grocery stores are beginning to carry them. These tend to be what are known as bacillus because they form a spore, and so they have a shelf life. They're relatively easy to store on the shelf. There's another kind, methyl pink bacterium, that you have to freeze dry. Those are also becoming accessible. So these things are developing, just like the mycorrhizal fungi did. And so now we're capable of growing a lot of the mycorrhizal fungi. And so it's coming, and we're getting there.
That's awesome.
Yeah, a lot of practical applications that all growers, all farmers ought to be taking they should Google rhizophagy search, so that and put it into your search engine, so that anytime something new comes up on it, or soil food web, you get that information sent to you. Google's the best tool you could use, or an internet search engine.
Hey there, it's Andy from the Poor Proles Almanac. Thank you so much for taking the time to listen to our podcast. As you can probably tell, this content involves extensive research and editing to release weekly episodes. If you think this content is valuable for the future that we inherit, please consider financially supporting this project by visiting poorproles.com and clicking on the Patreon, Venmo, Ko-Fi, or PayPal tabs. Every dollar helps offset our costs for hosting the podcast content and helps offset hundreds of hours of work put towards this project monthly. Thank you for supporting us by sharing, liking, and donating to this project. Together, we can build a better future. Yeah, the bacteria in the seed is just mind-blowing, because I feel like it explains so much about how people are able to grow indoors and basically have plants that can eventually have bacteria that makes sense in some capacity for that plant. And it gets me thinking about, with the Korean natural farming, you've got this idea of IMO 1, 2, 3, 4, and so on. And in a sense, you've already got IMO 1 in the seed. And if there would be a way to extract that process, create a bed that is full of that bacteria, so when you plant a seed, it's already there. It doesn't need to grow with the seed. Just like if it had fallen from, the plant above it, the mother, you know what I mean?
Yeah, well, there is a way. There's two ways. One is compost. Make your compost out of the dead plants, if you can. Not always easy to do, because a lot of time you harvest the plant, there's nothing to compost. But the other way is to, from my perspective, continue to grow in the same soil again and again, unless you're having a root problem. That soil contains the exudates, some of the bacteria, so you got a head start and don't rototill it, don't turn it over, just plant right in it. The plant will go right through old soil, and you end up with, I think, at least intuitively, more of the bacteria. I haven't done the research, but it makes a great deal of sense to me that's the way to go. And in my conversations with Dr. James White, who's at Rutgers University again, and people should check out his stuff. This is how the system works, and it's just an amazing. The soil food web is incredible. You're right. KNF has all these different formulations, but if you've got the soil food working, you don't need any of it.
Yeah. The goal is that you don't need it anymore, at least theoretically.
Right. And I know Dr. Elaine Ingham used to get criticized like crazy by a lot of writers, because that was, I don't want to put words in her mouth. I think that was one of the statements that she made. If your soil food web's working, you don't need to ever fertilize. As long as you're not violating the law of return, which says things that die from a plant should go down. That's how the plant continues to regenerate. So, it's a beautiful system. System. And this new book, Teeming with Bacteria, really fits in with the whole thing. So I've changed the order I think people ought to read my books. Definitely you start out with Teeming with Microbes, but then I would go to Teeming with Bacteria, and then I would do Teeming with Fungi, and then I would do Teeming with Nutrients. But I'd read all four of them, that's for sure, because they fit together. And again, I like to point out to people, I didn't invent any of this. I didn't do the scientific research on any of this. I'm just the reporter. And again, I tried to dumb it down so that I can understand it. And if I can understand it, anybody can understand it.
That was going to be my next question, is how it was kind of ironic that you ended on bacteria when you think of the cycle of natural succession. You usually would start with bacteria. It's just really interesting that you kind of did the opposite. Now you're saying to read it in this different order.
Right.
It's really interesting.
And that's just because the 30% of the nitrogen is a lot of nitrogen.
Yeah.
It's and of course they're so fascinating. And I've got this stick up, where, that we spend too much time with our kids teaching them about dinosaurs. We need to be teaching them about microbes. Boy, oh boy, they're fascinating. And they need to, they can say the names of the complicated names of these dinosaurs. They'll be able to just have these bacterial names flow off their tongue. I just got yesterday a copy of the audio version of Teeming with Bacteria, audible, I guess. And I can't, I haven't pulled it out of the cellophane yet to listen to it because I don't have a CD player. I can't imagine how anybody read this thing. I list the bacterial names, and there are lots of them, and they're very complicated. But by the end of the book, you get a feel for, I've seen that one. I know I need that one. And there are specific ones we know that specific plants need. And so I talk about that in terms of different crops, tomatoes and cannabis, and which is another whole interesting subject, because the trichomes on plants, it turns out, have bacteria in them. And they're doing the same thing. They're getting bombarded and they're bombarding back. In the case of cannabis, you get cannabinoids bombarding the bacteria. It's, it's really quite something. And there are bacteria all over the leaves and in the plant doing endophytic things like producing gibberellic acid or producing auxin. They produce phytohormones, and so they cause the plant to react in ways that help the plant. And again, they increase, their very presence increases the plant's ability to handle stress, be it abiotic stress, wind and heat, or even biotic stress, an attack, mildew, et cetera, et cetera. The bacteria there, and they got a good thing going. They want to help the plant as much as possible. So it's really an amazing, beautiful addition to the soil food web.
Yeah, absolutely. I do want to pick at a point you brought up earlier around the cycle. I can't recall the term you use. I've heard you use it like a number of times.
The rhizophazy cycle.
No, not the rhizophazy. About the need to make sure that plants, you're not taking more from the plants. The laws,
Law of
return.
Yeah.
And like I do think that's something we miss, or we think there's a way around it, that we can somehow not do these things if we're taking plants, consuming their fruit, whatever it might be, and not returning anything back, that there is a point where we will no longer be able to take anymore. And I think sometimes we try to find ways around that where we don't have to do those things. And it's really important to understand that this is a cycle. It's a zero-sum game. We have to, whatever comes out, something has to go back in.
And
right. The way we get around it is we put chemicals down. Well, that's not the way to get around it. As you say, that just breaks the cycle even more. So, you have a choice. You could put chemicals down, or you could put organics down. If you're taking out all the apples, then put all the leaves, from a different set of trees, or compost is phenomenal. All this stuff works. Food waste can be converted in. We don't need to necessarily use these chemicals. And clearly they're not helping the soil food web.
No. And the reason I brought this up is that you've talked too about this idea of this term regenerative agriculture as being, I guess you could say, like a misnomer, in that it's not really that we're regeneratively growing food, but instead that we're understanding more comprehensively the needs of the soil food web. So could you explain that a little bit?
Yeah, I mean, to me, regenerative. I think it's a better term to say soil food web than regenerative. It's the soil food web that makes things grow. When you're talking regenerative, and I think there is a time when you need to be talking about that. I think you're talking about something that's added to the soil food web. You've got to treat your employees properly. You can't be poisoning them or the animals on your property. You need to be using everything you possibly can from your property. That's regenerative to me. It's not quite the same as soil food web.
Yeah.
Yeah.
Does that make any sense? I don't know if that makes any sense.
Yeah, it does. And
we have all these different words for the soil, for what is essentially the workings of the soil food web. I mean, KNF, ultimately, you're feeding the microbes. You're getting them to feed the plant. That's soil food web.
Yeah, that's what it ultimately comes down to, is the framework which the soil is healthy enough to be able to effectively and efficiently produce the things that the plants need. And without that, then none of the other pieces kind of fall into place. And we tried to basically sidestep that with like petrochemical fertilizers. And obviously now we're kind of seeing the consequences of that.
That's true. That's very true. I want to go back and talk about something you and I talked about just before we started, and that's the fungal bacteria ratio. Since I'm so big on bacteria, people could have said the same thing on fungi. Yeah, I think there's sort of a misconnect. Again, intuitively, it just makes sense that when you start out on the left hand of the succession, when there's nothing around, it's just bacteria, there's no fungi because there's nothing for the fungi to eat. So as soon as you start getting plant material, you start attracting fungi. Not big numbers of fungi, but you start attracting it. So by the time you get, to where you're on the spectrum where we're growing food plants, you've got fungi in that soil, even though it looks like it's heavily on the bacteria side of the spectrum, as opposed to the old growth forest, which is heavily on the on the fungal side. It has bacteria just as you do in the other one. So, it might only have 3-4%, I don't know, 5%, but it's got fungi, and you need those fungi. And some of them are the mycorrhizal fungi. And again, I understand that there are plants that don't associate with the mycorrhizal fungi, But from my perspective, it's always a good idea to coat those seeds with a mycorrhizal fungi inoculant and see if you can get them going. If the plant's in the ground for 2 months, I think it's got an opportunity to be able to grow mycorrhizae. And note the difference. Mycorrhizal fungi form a mycorrhiza or mycorrhizae. Two different words. A lot of people refer to the fungi as mycorrhizal or mycorrhiza, which it's not. That's the root and the fungi working together. So, yeah, I mean, this is all just kind of intuitive stuff that we're working with. There are studies after studies after studies coming out on this stuff. If I was a student today, oh my God, the things you can take a look at. Do you get more mycorrhizal fungi if you let the rhizophagy cycle continue? Do you get less? I don't know. Some of these bacteria help the fungus break down the phosphorus. So maybe there's just so much stuff to study, and we're studying it, thank God, because we have to. We've got a lot of serious problems.
Yeah, what you're bringing up, I think, points to a really important piece of it. We have a really bad habit as a species of doing this, but like understanding that we don't know everything, and we're probably going to learn things that discredit part of the things we've learned, right? Like that's how history has always worked. We've learned things and we're like, oh, we thought this was a broad rule, but actually it's only in these particular instances. So to go back to like those really quick crops that we think of as needing only bacteria, maybe there are times when it does need those fungal relationships, or maybe there's something we don't know yet of what the benefits it might provide that don't look like on at first that there's any relationship. There's so much we don't know.
Yeah, Louis Pasteur, excuse me for interrupting. Louis Pasteur thought that plants were sterile inside, and he was wrong. We're all wrong all the time. Yeah, it's just something we just have to continually look at this stuff and see what works. Now, we do know some plants don't make a mycorrhiza. The cold flame, cabbages and, whatnot. Blueberries make a different kind. Orchids won't grow without a mycorrhizal fungi. So it's all, and think of there must be some relationship between the bacteria and these things and how they operate and grow. And there is, and it's in fact I describe some of it in the book. I mean, it really is an unbelievable dance. And the soil food web, whether you call it regenerative or whatever, is such an unbelievable system. It's just fabulous, and we're learning more and more and more and more all the time.
Yeah, it's great. It's exciting, and I feel like it's one of the last few areas that's where the average person can see something scientific that's being discovered and still like apply it to their daily life. I think science in a lot of ways has become really disconnected from the way we live our lives. Like when discoveries are made, unless it shows up in a medicine bottle or, in some piece of technology, it usually exists outside of the world we live in day to day, right? But if you're a gardener, the things that are being found, you can actually say, this affects what I'm doing in my garden. I'm going to do something different. And that's like, there's just something really cool about that.
Yeah, there is. There's also something pretty cool about just looking at a plant and saying, that's not a dumb stationary thing. It's an incredible working organism that's figured out how to get what it needs, even though it can't run around. They're amazing. I have trouble these days getting rid of weeds. They're a plant and they're doing these terrific things. It's just amazing. And the more you learn about it, the pictures of the rhizophagy or the rhizophagy cycle, just incredible. And they're getting better and better and better. I mean, Dr. Elaine would have seen this had the microscopes been capable of doing so back then. It's just incredible what's going on in terms of these beautiful discoveries. And Dr. White really works with his students, and they've done some studies that they're incredible. I mean, there's just videos of these things operating and things that 10 years ago, who could have thought about even seeing them? I mean, it's just, so we are learning more and more and more. The question is, are we learning, and are the right people learning enough? Are our farmers picking up? Are our chemical industry, is it picking up? Fortunately, I think it is. I'm seeing more and more biologicals. I'm seeing more and more research on which particular plant is impacted by which particular biological. It's really quite heartening in that regard. So I think the big guys with the complicated names who we like to stick our tongues out at, I think they figured out they can make a lot of money by selling bacteria, a lot of money. And so I think we're fortunate in that regard. We as gardeners are going to end up being some of the beneficiaries of it.
I mean, I hope you're right. I'm not as optimistic, but I hope you're right that things can change, because we're in a bad place if they don't.
We are. Yeah. But I mean, I've seen research, for example, of microbes that hop off of one plant and kill the weeds that impact that plant, and then hop back into the plant again. Holy crow! Forget glyphosate. Give me that bacteria. Roundup. Forget that. So yeah, I think we're going to get there. We have no choice but to get there. We just simply don't have a choice. And if we don't team with the microbes, and team with the fungi, team with the bacteria, probably team with the viruses as well, we're going to.
Is that the next book?
Finished. No, next book. I don't think there is one.
Oh,
these are really. You got to go down into the rabbit hole to write a book, and it's fun doing it, but it's not fun for the people around you.
One of the interviews you were talking about, like, you write a book and then after you're like, I'm never doing that again. It's like giving birth, and you're just like, I've done it, I don't want to do it again, and then you kind of forget about it after a while. But I totally get it right now, like in the throes of it. But Jeff, where can people find your book?
Well, they can find all of them on Amazon. Okay. Or
is there anywhere better for you? Yeah.
No, it doesn't make, the publisher makes the money. What I get is the satisfaction of knowing that people are growing properly and doing it the right way. Make sure that you understand that the books begin with the word teeming, Teaming, and not Teem. We're talking about getting together with these things and making them work. And so teaming with microbes, again, is the first one you start with. Take a look at the reviews. I think you'll see it's worth looking at.
Yeah, it's been great. I've read all of. I haven't read the fungi one yet. I have it. I just haven't read it. So that is next on my list. Even though I should buy the new one next, because like I said, I was listening to you talk about it before this interview, and I definitely need to get my hands on it now.
Well, you need to read both of them. I mean, again, It's not because I wrote the books. The subject matter of these books is the science behind food web and organics. And so you really need to understand that if you're going to practice it.
Yeah. Jeff, this has been really fun. I've had a blast chatting with you. Thanks so much for coming on.